Okay, it's been forever streaming, bro. Been streaming forever. Okay, studying for the SAT. Stuck on this question. It is the area of the region covered when is rotated. Okay, so technically it's a circle when it's rotated. A semicircle is pi times. That's a diameter. 180 degrees about point B. Boop. So I thought it should be like this. But apparently, it's not. Okay, so I'm just gonna have to ask later. But GT35 can come back to it. That's okay. Okay, dude, I'm so lost on circles and tangent chords. Don't know what I'm doing, but it comes to these. But all right, let's just do this. And then we do a little bit of no writing character. And the figure shown angle QRSQR. Oh, QSR and QPR are inscribed in the circle. Which of the following statements must be true? So we can automatically cancel this out, right? Because typically on the SAT, there's not enough information. We usually be wrong, right? And it's inscribed. Oh, by the way, I forgot to say, but I'm doing I'm doing the test master's book right now because I took the course. In case anyone wanted to know. Wait, it actually might be there's not enough information to know. A chord is a line segment that connects two points in a circle. The diameter is also the longest possible chord. A tangent line is a line that touches a circle at exactly one point. A tangent is always perpendicular to the radius it intersects. The measure of an angle inscribed in a circle is half the measure of the central angle. Wait a second. Shoot. I don't know this. I'm assuming it's D. It's C. It's equal. How do you know it's equal? I'm not gonna watch it on Academy. So I'm not gonna hold you. What? Oh, what's up? Scarlet. The hell? Mm, What? Oh dang! You do the same thing I do. Uh, you do the same thing I do. You also do math and stuff, but I just do it for fun. But whatever. That's crazy. All right. I'm looking lost on this. So I'm gonna have to watch a Khan Academy really quickly. Wait. Mm, inscribed angles circle. Yeah, let's watch this.
A lot of different kinds of problems, including some that have a little bit of algebra with them. First off, let's talk about some definitions real quick. So we have a circle, and you may have already talked because they share that arc, the size of the central angle and the size of the inscribed angle are related. So let me show you how that this point and pull it back. I am creating an inscribed angle. The intercepted arc is 100 degrees and this is 50. Now I could have put that anywhere I wanted as long as I stayed on the circle. If I took this thing off the
QSR
circle, it changes. But if I stay on the circle,
QPR
it's still
uh,
thing off the
R
circle.
the heck?
Still 50 degrees. Now to see that with the central angle already on there, this is how they're related. The central angle is going to equal the arc measurement and the inscribed angle is going to be half of the arc measurement.
Oh,
For the first
okay,
example,
okay,
you
okay,
might
okay.
get
I
it.
got it, I got it, I got it, I got it. I'm so slow. I'm actually so slow. The reason they're the same is because both of them share this arc right here. That's why. All right. Um, this I'm still lost on. Pretty sure this just has to do with me not understanding what they mean by rotated. But we will never know. Yeah. In the circle above. Wait, how did I get 26 for this? Oh, because these are perpendicular and then, okay. Yeah, that's pretty simple. In the circle above, point O is the center. The diameter AC bisects BD at point E. The radius of the circle is 6 feet. CE equals 2, or the radius of the circle, CE equals 2, CE equals 2. It's BE equals root K. What is the value of K? Root K. Well, I need to use a restroom. Okay, E B E it bisects this, right? Mm, well, I'm low-key lost, but I would assume it would be 4. I assume it'd be 4. What the? Oh, no, no, no. Yeah, no, I'm lost. I need to go over the circle theorems. That's what I need to do. Can you bring the camera a little closer? I can't. I just, I literally can't. Uh,
Hi,
in fact, I can't bring. Literally, how do I do that? How do I do that? Like, cause I'm using this. Like, what you want me to do? Like that? Like, it's so blurry anyway. It doesn't matter. So blurry. But this is a question I'm working on. Yeah, I'm sure you can pause if you wanted to look at it. Okay, wait a sec. Why the heck am I not able to do this?
Tammy and I do math for coffee today, and this is 50. Connecting back, and you can see they're connecting back to D. And so we have an inscribed angle of 71 degrees that's going out to arc BC. We figured out already just from the last demonstration that the inscribed angle is going to be half as big as the arc, which means we need to take 71 and double it. And our answer is 142 degrees. That is the measurement of the arc from B to C. You are looking for the arc that goes from A to B or B down to A, this thing right here, and we have 70 degrees. In geometry, you can assume that if you have a line connecting 2 points on a circle that goes through the center, then that line is a diameter. And a diameter cuts a circle in half. So we do know that this arc that goes around the circle from B to G is a semicircle, and that is 180 degrees. We already know that part of it is 70 degrees, so let's subtract that. And so the arc from D to G is 110 degrees. That's not the answer because we have to go back to the angle. Well, the arc is always twice as big as the angle, so we just need to divide 110 in half, going to the points B and D, which means they are both intercepting the same arc. That means they have to be equal to each other. 17x plus 4 and then set that to the 36x.
Well, this isn't
So it's your
inscribed
choice.
angles. What am I doing? This is.
Hi, I'm Tammy and I do math for
This is. Bisecting. In lines and circle. Let's watch.
Okay. The next, and on this circle, what we're going to, guess what? That diameter bisects the chord. So now I can say that EG is congruent to line FG. So when you have a diameter that is perpendicular to a chord, it cuts it in half. It bisects it. And you guys remember doing a lot of problems with bisection, right? Yeah. Remember bisection, that means each side is equal to each other. So I could say 3x minus 14 here, and then 5x plus 2 is here. And I say find x, and you say, oh, set these equal to each other, right? Because they're bisectors. That means each half is equal to one another. And then you solve for x, right? Yeah. That would like be a problem, hint, hint. But that's not it. I could also, there's also two other things that happen with this. Yes?
Could you connect like A and B and A and F and then use the bisector C like that?
Say what?
Could you connect like AF and AE and then use C as the bisector and AE as the
You mean AC and CD?
Oh, the problem is I have you asking a question, and then I have other people talking, so it's kind of hard for me to go over this. So you want to connect AE.
Yeah, and then AF.
Yeah.
And then use AB as like a bisector and you get your measurements that way. And then you have all equal sides.
But what are you bisecting of what though? But yeah, there'll probably be problems that you can connect with that. Okay. Yeah. Let me just finish up the last thing I want you guys to understand is actually kind of going to your point, let's connect these back. What I want you guys to understand is if these two are equal, these two are been bisected, right? What do you guys think about the measurements of these arcs? Do you think those look like they would be equal as well? Mm-hmm. Yeah. So now we can say that the measure of arc EB is also going to be congruent to the measure of arc FB. All right? Now, the converse works like this as well. If I give you guys a circle and I say that's 30 degrees and that's 30 degrees, can you guys tell me that that's perpendicular? If these two arcs are equal, then that's perpendicular. All right? That's that they're then you can show that they're perpendicular. I say what's this? Variable.
Wait,
I say,
bro, what am I? What the, dude? How am I so?
equal. Then I ask.
Do you think you would be in this video?
This is the angle. So say a quadrilateral straight line. The angle at P. Then draw a line from the center of the circle to P. Then this line will split that angle in half. Or we could say it bisects the chord from the points with the chord is equal to this angle that the chord makes at the circumference. The same happens with the chord on the other side as well. Here's a quick sketch of all of those theorems we've covered on one page. So, in an exact theorem, a tangent meets 94 degrees, since 86 equals terminal twice the area of the circumference ACD.
Hey everyone, it's that mathematician and the purple line equal. Now a quick fact about the perpendicular bisector of a chord. It always goes through the center of the circle. Notice there that green line goes through point C. So my perpendicular bisector also acts as my diameter. It's that mathematician, and I'll see you on the next video. Hey everyone, it's that mathematician. On this video, we're going to continue to look at circles and some facts about them. Notice my...
Bro, what?
Chord AE, and DC and CB are the two segments. It has to be 5 since this is a radius, but since this part is
Very nice.
3, this piece over here would have to be 2. And now I can treat this as two chords intersecting in a circle, just like we did for the first part of this video. Now be careful here, this segment of the chord is actually 5 plus 3, or 8. So we would have 8 times 2 is equal to x squared. That means
Wait a second. So here would be 10 times 2 is equals to root k squared. So then k is equals to 20. And then that's the right answer. But
16 is equal to x squared, and x is. The second part of this video, we're going to look at a specific instance of two chords intersecting, where one of those chords is a diameter, and they form a right angle. This problem is intersected. Here's an example of this piece, but this piece is 10. Now, since this is a radius, that means this has to be 10 as well, which means this missing chunk has to be equals 8. But remember, they're looking for AB, which is 2x, so AB is 16. Has to equal the product of the segments of the other chord. So these are the two segments of this chord, and 3 and 6 are the segments of the other chord. Since the product of the segments of one chord has to equal the product of the segments of the other chord, 2x is equal to 18 and x equals 9. And that's really all there is to it.
okay, I didn't know this rule, but that's good that I know now. Okay. And wait a second, I got a good idea. What happens if I bring it? You want it here, right? Oh, never mind. Never mind. Um. Uh, I'm lost. I'm lost, bro. The SAT, bro. Oh my gosh. The graph of the given equation, xy plane is a circle. So we are allowed to use decimals. So I'm gonna just graph this really quickly. X squared plus y minus 1 squared is to 1. So that's the graph. And then a new circle is drawn. A new circle is drawn. Whose center is 1 unit down from this circle and whose radius is 4 more than this circle. Okay, one of the things you can do, which is really quick, is instead of solving, you can plug it in to Desmos, which is very quick. If you have fast UVs. So 1 unit down and then 4 more. So the radius of the circle is 2. So the 4 more than 2 is going to be 6, right? Yeah. 4 more than 6. So this isn't going to be it. Plus 25 plus 5. So this isn't it either. So x squared plus y. Wait, x squared plus y plus 1. Okay. So we know D is the answer. Very quick method of just plugging in and checking. Because there's 1 unit down. Oh, what? How does that even make sense? There's 1 unit down from this circle, so its center would have to be over here. The radius is 1, 2. Okay, what am I doing? Okay, so the radius of this is 1. So the radius of the next one is going to be 5. And then 1 down, so... Okay, this wasn't it. Plus 5. What am I doing, bro? That should not taking that long, but that's because my plug and check was a bit slow. You can work on that. Which of the following equations describes a circle with a radius of 10 that passes through the origin? When grabbed in the xy plane. So this also is just another Desmos thing where you can just do delete all x minus 5 and then squared and then plus y plus 5 squared equals 10. So a radius of 10 that passes through the origin? Nope. And then you can do x squared y plus 5 squared equals 100. Nope. X minus 5 root 2 y plus 5 root 2. You just let it be? You let it be. Yeah. With a radius of 10. With the radius of 10. So 2.29 Okay, it's gonna be this one. X squared and y squared. Mm, and then India, beta, India. I'm from India. Oh, when you say where you from, you mean like where am I living? Oh shoot, U.S. U.S. I ain't from India. India's too much. Alright. In the figure above, square or W X Y Z has sides equal to 2. Z is the center of the circle. What is the area of the region shaded? Alright, so okay, so what we can do is 4 is the and then pi r squared. So pi 4 pi minus 4 is the answer. 4 pi minus 4. Oh no, what am I doing? That's not the answer because 4 pi minus 4 is the area of the circle. Eh. 4. It's just pi minus 4. It's 4 minus pi. Or at least it should be. So area huh? Brother. Ugh, the heck? Oh, this is the example. Oh, I was about to say, bro. That's doing too much. Nine. None. 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 Bro, I just said I'm not from India, bro. I'm Indian, but I'm in the U.S. right now. Cause what am I saying? Cause um I was born in America. Indian heritage, that's what it is. Shit, bro. What the I'm going to 11 and in Texas. Bro, this guy, bro. Alright, stick to you. Bro, stop, John, stop. Huh? Bro, don't say that, bro. So you're gonna get our eyes IP'd. Can you not? Can you literally not? You're actually gonna get us IP'd. I'm just kidding. He's lying. We're not. In the figure above, square RST used inscribed and square. Huh? Oh. A, B, C, D measures X inside of R, S, T, U. What the? Doesn't mean why? What is the area of the shaded region? X squared minus y squared. That's not too bad. That's a very simple question. Is that B? Area of shaded region B. Okay, nice. I'm gonna have to start doing my grammar practice, bro. This is too much. Too much, but I'm gonna start doing grammar after this. Okay, I'll do this, right? Three objects, let's see. Yeah, and then I'll go, and then I'll go do grammar. Okay. Two identical rectangular prisms each have a height of 90 inches. Rectangular prisms have a height of 90. Just enjoy drawing. A height of 90. The base of each prism is a square. That's pretty obvious. The surface area of each prism is q inches squared. Prisms are glued along a square base. What is the side length in inches? Bro, what? Two identical rectangular prisms. Okay, so if it's 4, it's 90 times 4. Bro, what type of a problem is this? Okay, wait, I'm just gonna not do this because I'm not in the mood for math anymore. I've just been doing it for way too long. I need to do some no red ink or something. Let's do like here. Let's do some no red ink. And then no red ink. Oh, I already have it open actually. What am I doing? Okay. Mm, but actually, no, we don't even need that's freaking camera anymore. This. Let me hear this now. Oh man, oh. Okay. Oh. What? Bro, I'm cooked. What just happened? Prince Loder decided to buy a rosemary plant. No punctuation. When Swaby joins in two independent clauses, okay. So pretty much, Swabies means you don't use commas. And Sloter wanted a good grade on his spelling test. The teacher asked and her friend, oh, dang, dang. So it's just Swabies I didn't know. Demo, should I do it? Okay, I'll just do it. Yo, what's up? B-Bang Clips. What's up? B-Bang Clips. Let's see what you do. You do. MMA. MMA.